All right, hello geometry honors. Today we're going to look at volume and surface area of spheres. And we've got a bunch of vocabulary here, and we're just going to knock that out real quick since it's a video. But a sphere is the set of all points in space equidistant from a given point. So let's write that down. All points in space equidistant from a given point. All right, so I think you can kind of imagine that. The point that they're equidistant from is called the center of the sphere. And similar to circles, a sphere has a radius, and it's a segment from the center to a point on the sphere. And a sphere also has something called a chord whose endpoints are on the sphere. It's a segment. And we'll illustrate that down below here in a second. Or actually, we can do that real quick. So a chord is just you're on the sphere somewhere, and then you're connecting to another point on the sphere somewhere. So it could just be you're there, and then you cut across to there. You're going to be passing through the interior of the sphere to do that. But yep, that's a chord right there. We've got our radius, which is the center out to a point on the sphere. So there's a radius right there. We'll label that. Okay, and similar to circles again, we've got a diameter, and it's going to be a special type of chord. It's going to be a chord that contains the center. And then something that is a little less familiar is the great circle. A great circle of a sphere is a circle in a plane that goes through the center of the sphere. So a lot of times when we look at spheres, we can't help but think of the planet we live on. And so when we think about the equator goes around, the equator is a great circle of the Earth. If you were to slice through the equator, you should go through the center of the Earth. So it's kind of an interesting idea. But the great circle, is a plane that goes through the center of the sphere. And finally, a hemisphere of a sphere is exactly half a sphere. So we're going to be using this vocabulary here in a bit as we do work through some problems. To find the surface area of a sphere, it might be helpful to think about, I don't know if any of you are familiar with what a baseball looks like. I should have like a picture to show you or something. But if you take a baseball and the way those seams are, if you were to undo all those seams and fold it out, it's kind of interesting. What you would have when you lay it all flat is it kind of looks like you have 4 different circles. They're not quite circles, but there's extra space connecting them and things like that. And it turns out that's a very good approximation of the surface area of a sphere. So basically, you take the area of one of the circles and multiply it by 4. So it's 4 pi r squared. For volume, I've seen it described as splitting up a sphere into a bunch of little pyramids and then approximating the volume by adding up all those little pyramids. And that kind of illustrates where part of the volume formula comes from. So the volume formula, because you're finding volume, you're going to need a cubic unit, but it's going to be the radius cubed. So you got pi r cubed, but then you've got 4/3 out front. And our book does have a not so great explanation of this formula, but yeah, you're free to look at that if you'd like. So these formulas are a little bit difficult because you kind of just, they're not as intuitive as some other ones that we look at. So for surface area, 4 pi r squared. For volume, 4/3 pi r cubed. So let's try some out. For our first example, find the surface area of a sphere, and we are in luck because they gave us a radius, didn't they? So surface area, 4 pi r squared. And our answer in terms of pi, otherwise known as an exact answer, is 576 pi feet squared. But if we approximate it, you'll get 1,809.56 if you round it to the nearest hundredth feet squared. Not so bad. For example 2, they're wanting us to do something a little bit different. They're giving us the surface area, and they're asking what the diameter of the sphere would be. So we're still going to use the surface area formula, S equals 4 pi r squared. But, let me move those out of the way. But we're given the surface area. And from there, what can we do? Well, if our goal is to find the diameter, we can solve this for the radius and then double it, and we'll be done. So at this point, I'm going to divide by 4 pi, divide by 4 pi. It's nice because the pi's divide out to make 1. 40.96 divided by 4 is 10.24. That's equal to r squared. How do we undo an r squared? We square root the squaring of it, and we get a pretty nice answer of 3.2, and that would be inches. But that's not our diameter, that's our radius. So we just need to double it to get our diameter. All right, example 3, we've got a globe. And it says the diameter of the globe is 18 inches. They want us to find the surface area. So if the diameter, so we're still using that same surface area formula, 4 pi r squared. But if the diameter is 18 inches, our radius is going to be 9. So no big deal here. No big deal. And our answer in terms of pi, otherwise known as our exact answer, 324 pi inches squared. But if they want us to get a rounded answer, 1,017.88 rounded to the nearest hundredth inches squared. Okay, so few surface area problems. Hopefully we're feeling pretty good about that. Now let's move on to some volume examples, it looks like. It says we got a beach ball with a diameter of 15 inches, find its volume. So now we're going to use the volume formula, 4/3 pi r. Remember, it's volume, so it's cubic units, so we're going to cube it. And we will have everything we need to know because we can cut that diameter in half to get our radius. And yeah, 15/2, or we can do 7.5, I suppose. And again, we can get an exact answer or an answer in terms of pi. And I get 562.5 pi inches cubed. But be prepared to round it to the nearest 10th or 100th, depending. And I get 1,767.15 inches cubed. Now these next examples are composites. So there's more than one shape that we're going to be calculating. And it says, yeah, find the volume of this composite. So it's kind of like a, I don't know, like a pill shape, I guess. So it looks to me like we've got a cylinder in the middle and we've got two hemispheres. But since it's a right cylinder, everything looks good. Yeah, those radiuses are the same. Essentially what we're doing is we're finding the area of one whole circle, so 4/3 pi r cubed, plus the volume of that cylinder. So to find the volume of a cylinder, you take the area of the base, so 4 pi r squared, and multiply by the height, and in this case the height of the cylinder is 7 centimeters. So we have everything we need to do what we need to do here. So let's fill in radius of 2, radius of 2, height of 7. Simplify this all down, leave it in terms of pi, and our exact answer is 38 2/3 pi centimeters cubed. Our rounded answer is 121.47 centimeters cubed. And on this last one, find the surface area and the volumes. We've got a little bit of work to do here on this one. So I'm in a volume state of mind, so let's do that first. We've got a composite again. We've got another cylinder, so pi r squared times height. But this time we have a true hemisphere to do. So we're going to do half of the volume of a sphere. So 1/2 times 4/3 pi r cubed, plus we'll have the area of the bottom, pi r squared, times the height. So this is volume. Let me label that because we're going to do surface area next. So let's see. I think we have everything we need to know here. This will simplify down to 2/3. I'll do that real quick. Radius is 4. The height of the cylinder was 4. And I get, when I simplify that all down, 106 2/3 pi meters cubed, otherwise known in rounded form as 335.10 if I round to the nearest 100th meters cubed. And lastly, we need to find the surface area. So for surface area of a sphere, we do 4 pi r squared, but it's half of 1. And then we got to be careful here because we've got the bottom of the cylinder, so that's pi r squared. But then what we have to get is this lateral area of the cylinder, and the lateral area of the cylinder would be like if we unwrapped it and laid it flat. Well, it would be a rectangle, and one length would be the circumference of the circle, and then the other length would be the 4. So what we're going to do is we're going to get the circumference of the circle, 2 pi r squared, and multiply by the height. So notice, class, here in the middle, none of that's exposed, so that's not going to be part of our surface area. So we don't need to add that other part of that second circle in there. It's not going to be on the outside, so it won't be involved with our surface area. And this is the setup we got. I'll plug everything in. Oh, I don't know if anybody else caught that, but circumference is not 2 pi r squared. Circumference is 2 pi r. And when I multiply all that together, I get, and add it together, I get 80 pi meters squared. And as a decimal, 251.33 meters squared. And there we have it. So practice is on Canvas. Thanks for watching.